Okay, so we're going to, for this worksheet or for this practice problem, we're going to be talking about aromaticity and anti-aromaticity and how to determine whether one is aromatic or not. So I have two compounds right here, and we're going to start off with the one on the left. So for aromaticity, there's four checkboxes that you have to check off. So whether it's planar or not, conjugated, cyclic, or Hughes law, if it obeys Hughes law. And if you have all of those checked off, then you're aromatic. So for this left one, I think one of the confusing things about this one is the carbocation. But something that you should note is when you have a carbocation, a carbanion, oops, or a radical, you are sp2. Okay, so then let me check if I have my. Okay, cool. So then we can check if we're completely conjugated because we know that conjugation is at least three consecutive sp2 atoms in a row. So I'm going to highlight all my sp2 atoms. So it's this one right here, this one right here, this one, this one, this one, this one. So that's sp2. And then we just found out that that carbanion is also an sp2. So then we are completely conjugated. And if you're completely conjugated, that means you're also planar. If you have complete conjugation in your compound, you're planar. Are we cyclic? Are we in a cyclic molecule? We are cyclic. And so the last thing that we have to find out is whether or not we obey Hughes' law. So Hughes' law is, let's see, just in case, 4n plus 2 equals number of pi electrons. Number of pi electrons. And this will vary between what compound you're given. And so for this compound that we're given, remember that in a double bond, we have a sigma bond and a pi bond. So on that pi bond, every bond has two electrons that make it up. On this pi bond, we have two pi electrons, I'm sorry. We have two pi electrons. And so we're able to count the electrons on this double bond. 1, 2, 3, 4, 5, and 6. And then the carbanion, there's no electrons in that place, so only 6 pi electrons. Place it in here. 4n plus 2, do some algebra, and n is equal to 1. So if your Hughes law is a whole number, so 0, 1, 2, 3 onwards, then we are aromatic. It obeys Hughes law. So n can be 0, 1, 2, any whole number. Okay. Then we look at the one on the right. And so what's going to help us out on this one, because this one might look a little bit confusing as well. I have two molecules right here. I have pyrrole and pyridine. And so both of these are aromatic, but the key to this one is counting your pi electrons. So something that I was told by my star tutors, when you have a double bond directly on your heteroatom, the p orbital is already taken over. So something that you should also know is when you're able to resonate electrons, you're in the p orbital. These electrons right here, I am able to resonate them in to the cyclic molecule. And when I resonate, I'll just draw my resonance structure. Since I'm able to resonate these electrons into my molecule, that means that I am in the p orbital, that these lone pairs are in the p orbital, meaning they're pi electrons. When they're able to resonate, they're in the pi electrons. So on this right one for pyridine, you already have a double bond directly on your heteroatom. So since something is already taking over the p orbital, these electrons right here can't be counted, right? So then you only count the double bonds for this one. 1, 2, 3, 4, 5, 6. 6 pi electrons on this one. And then on this one, you do it again. 1, 2, 3, 4, 5, 6. 6 pi electrons. So the key is knowing what orbital they're in. So the one on my left, my chiral, is going to be in my p orbital. My lone pairs are in my p orbital. Whereas the one in the right, pyridine, the lone pair is in the sp2 orbital because something is already taking over the p orbital. This bond right here, this double bond, is already taking over the pi electrons. Okay. So then we look back here. We have to determine whether these electrons are in the sp2 orbital or in the p orbital. So since there's no double bond directly on my heteroatom, there's nothing taking over the p orbital, that means I am able to resonate this lone pair and that this is in the p orbital. So these are pi electrons that you can count when you're doing your Huckel's law. So then I'm going to start counting. This double bond has pi electrons on it, 2 pi electrons. So 1, 2, 3, 4, and you count these 5, 6. So then you plug that into your equation as well. And I get n is equal to 1, which is the whole number that we want. So Huckel's law is checked off. Is it cyclic? This is a cyclic molecule. Is it completely conjugated? Well, let me highlight my conjugated parts. So this one's conjugated, this one's conjugated, conjugated, conjugated. And this, okay. Since you're able to resonate these electrons, your resonance structure should look like this. I'm going to resonate it to the right. Okay, so my oxygen here is in the sp2 orbital. So you always need to check the resonance of your heteroatom. Can those lone pairs on my heteroatom resonate? Yes, they can. So when you draw the resonance structure, is it sp2 or sp3? You take the lower state, so it'll be sp2 in this case. So this is also sp2. So then we are completely conjugated. We can check that off. And since we're completely conjugated, we are planar. Cool. So both of these will be aromatic and aromatic.